Okay, let's work through these problems, see how they work. So most of these look like you have to define the variables and then set up two equations and then solve these equations. So if we look at the first one, we are trying to find how much to invest in two different accounts, some in a account with 6% interest and one with an account with let's see, 7% interest. So what I would do first is I would define my two variables, so I'll call them x and y. So I'm going to call x the amount that is going to be invested at 6%, and y is going to be the amount invested at 7%. Now we have two pieces of key information in this problem. There's a total of 30,000 and the interest I get is 1930, and it's just simple interest. So I'm going to try to set up two equations. The first one, since there's a total of 30,000, I'm going to take the amount I invest at the 6% plus the amount I invest at the 7%, and that's going to equal the total of 30,000. Now for interest, simple interest is simply a percentage of the total. So if my amount x and my amount y, I'm basically getting 6% of whatever x is. So the way I write that is I write 6% as a decimal, so 0.06. Remember, just move it over 2 decimal places to the left. So 6% x, that's the amount of interest I'll make on the x account. And if I add that to the interest I make on the 7% account, which is 7% of y, that should be $1,930. So the first step is to get these two equations. Once you get that, then we can solve it. Now, the ALEKS program tells you to use the graphing calculator. I think that's a bad idea. I think it's more work than it has to be. I'm just going to solve them algebraically. So what I'm going to do is I'm going to take one equation. I'm going to take this equation, and I'm going to get y by itself. So if I have x plus y equals 30,000, I'll just simply subtract x from both sides. So y equals 30,000 minus x. So now what I'll do is I'll take that and I'm going to plug it into the other equation. So wherever I see y, I'm going to replace it with 30,000 minus x. Because the first equation tells us y is equal to 30,000 minus x. So I can replace anywhere I see y with that value. So now I'll just solve that once I plug it in. So plugging it in, I get 0.06x plus 0.07, and instead of y, I'm going to put 30,000 minus x, and that will equal 1930. So now you see we only have one variable. So now it's an algebraic equation, not the prettiest algebraic equation, but one we can deal with. So I'm going to distribute the 0.07 by multiplying that to both of those. So I'm going to get 0.06x. 0.07 times 30,000 is 2,100 minus 0.07x equals 1930. Well, now you see that there are two terms with x on the same side. So I could simply use your calculator, whatever you want to use. 0.06 minus 0.07 is negative 0.01x plus 2,100 equals 1930. So they are on the same side, so I just put them together. I'll move the 2,100 to the other side to try to get the x by itself. So 1930 minus 2,100 is negative 170 equals negative 0.01x. So then I'll divide both sides, by negative 0.01. Now obviously you should get a positive number at the end. If you get a negative number, something's gone wrong. So my x value is going to be 17,000. So x is the amount at the first account, so my first value is going to be 17,000. So ALEKS says first account, so this is my first account. Now how I find my second is I could just use this equation here, which is y minus 30,000x, because I know what x is. X is 17,000. So y is going to be 30,000 minus 17,000. So y is going to be 13,000. So those are my my two values. Now, I did substitution instead of the Alex calculator. You could certainly do elimination. Any method to get a value for the two variables, but the key thing is you find these two equations and then you solve for their variables. Now this problem deals with boat speed and things like that. So we have to remember a very simple equation from physics, and that is distance equals rate times time. So we're going to take the distance a boat travels is equal to its rate, how fast it's going, times its time, how long it takes to get there. So what we know is we have some information, so I'm just going to kind of make a little chart, and then we want to figure out what we want to do. So what we want to find is we want to find x, which is the speed of the boat in still water. So if there were no current, how fast would the boat go? And y, we want to know the rate of the current. So how fast is the river going? So we have this river. The water is pushing in some direction. We want to know how fast that water is going, and then we want to know if there was no current, how fast would the boat go. So this equation actually is going to be very, very helpful for us in creating our two equations, because just like before, we're going to try to create two equations. So in these cases, I kind of like to make a little chart. So I want to find the distance, the rate, and the time based on the information in the problem. And I'm going to have two different situations here. So one is going to be going upstream and one's going to be going downstream. Now when you're going upstream, that means you're going against the river current, so it's going to slow you down. It's like walking when the water is coming towards you. Downstream is when you're walking in the same direction of the current, so it almost pushes you from behind and makes you go a little faster. So the first thing says when I'm going upstream, it says I'm going 156 kilometers, so that's my distance, in 6 hours. It doesn't tell me much about the rate, but I will find that. And then downstream, it says I'm going 240 kilometers, obviously further, in the same amount of time, 6 hours. So I have everything figured out. The only thing I don't have figured out is I don't have my rate. But I'm actually going to define my rate based on these variables up here. So this is a very common problem. Sometimes you'll see these with airplanes, things like that. But if I'm going upstream, my rate is going to be my current rate. I'm always going to start with how fast the boat goes. And then the current is either going to speed me up or slow me down. So if I'm going upstream, I'm going against the current. The current is going to slow me down. So I'm going to do x minus y. And if I'm going downstream, the current is going to speed me up, so I'm going to go x plus y. So this is my chart. This is how I'm going to get my two equations. So one of my equations is going to be this line, and the other one is going to be this line. Because remember, I said distance equals rate times time. So I could say 156 equals rate, which is x minus y, times 6. And I could do 240 equals x plus y times 6. Now, one way to do these problems is to distribute the 6, but there is a trick, and this works pretty much all the time in Alex. What I'm going to do is I am going to divide 6 to both sides before I distribute, because I'll just get easier equations. So 156 divided by 6 is 26, equals x minus y. 240 divided by 6 is going to be 40, equals x plus y. So now my goal is to solve these two equations for x and y, and then I'll have my speed of the boat in still water and the current. So in the last problem we did substitution. That would certainly work as well, where you could get one variable by itself. You could also do elimination, it doesn't matter. I'll just continue to do substitution. I'm going to take this equation here, and I'm going to get x by itself. It doesn't matter which one you get by itself. I'm just going to get x by itself because I think it's a little simpler. So that makes it 26 plus y. And then remember, I will plug that into the other equation. So that's going to be 40 equals 26 plus y plus another y, because the 26 plus y takes the place of x. So that gives me 40 equals 26 plus 2y, because I've got a y here and a y here. I'll subtract 26 from both sides. So 40 minus 26 is 14 equals 2y. And I'll divide both sides by 2, so y is 7. Now remember, 7 is the rate of the current because it's y. So my rate of my current in this problem is 7. Now if I would have solved for x first, then I would have found the speed of the boat in still water. So now I need to find x, but I can always go back to one of the equations. It doesn't matter which one. I'm going to go back to this one. I could honestly go back up to these green ones way up here, but that seems like more work. So this says x equals 26 plus y, but remember y is 7. So x equals 26 plus 7, which is 33. So then the boat in still water is 33, and it would be in kilometers per hour. So again, you just got to figure out how to set up your equations. Now the last one is very similar as well, where we're going to talk about the area of a rectangle. We're going to set it, but this one is going to be solved with a quadratic equation. So this is one where you're going to have to use some of your factoring. So since it's a rectangle, I'm going to draw a picture. So we have a rectangle that looks like this. So the area is 14 meters squared. And if you remember, the area of a rectangle is just length times width. So it says the length of the rectangle is 3 meters less than double the width. So I'm going to call the width x. So this side would be x as well. And the length, which is the other side, is 3 meters less than double the width. So I'm going to double the width and take 3 meters less than that. So that's going to be 2x minus 3. So this is length, and this is width. So what I'm going to do now is I'm going to use this very basic relationship to make my equation. It's not going to be like the last couple because it's not linear. This one is quadratic. So the area 14 equals x, which is the length, or is the width, it doesn't matter, times 2x minus 3. So I did width times length. You can certainly do length times width. I just like to have the x out in front. So now I have to solve this like a quadratic. So I'm going to distribute the x. So I get 14 equals 2x squared minus 3x. Since it's got the squared and the x now, it's quadratic. So the way to solve quadratics is get everything to one side. So we get 0 equals 2x squared minus 3x minus 14. Now there's lots and lots and lots of ways to factor this. Unfoil, whatever you want to do. I know the first spot in each one has to multiply to 2x, so 2x and x. I know the last two spots have to multiply to negative 14, and when I FOIL it out, it has to equal negative 3. So I'm going to do an incorrect one first just to see how it works. So let's say I did negative 7 and positive 2, because that multiplies to negative 14. But if I FOIL it, you'll see I get 2x squared minus 14x plus 2x minus 14. But these two add to negative 12x. But notice I want negative 3x. So that's not right. So what I'll do is I will just change them. You can change the position. I could do 14 times 1. But I'm just going to switch these like this, see if it works out any different, because when changing the position, it actually can make a difference. So in this case, this is the right factorization, I believe, but let's just check it. So that's 2x squared. That's 4x That's negative 7x, and that's negative 14. So those two together give me negative 3x. So 0 equals 2x minus 7 and x plus 2. Now we have it factored. This is where we take each factor. So we have two factors, and we set them equal to 0. So 2x minus 7 equal to 0, x plus 2 equal to 0. So if I solve the right one, I'm just going to subtract 2, so x is going to equal negative 2. We'll talk about that in a second. If I solve the other one, I'll add 7, so 2x equals 7. And then I'll divide both sides by 2, so x equals 7 over 2. Now, one of these is no good. And the one that's no good is the negative. Because x, remember, was our width. I can't have a width that is negative. So that's no good. So x of 7/2, that is going to be my width. My width is going to be 7/2 meters. So finding the first one is definitely the hardest one. Now for length, remember I have length is 2x minus 3. So the length is going to be 2 times x, which is 7 over 2, minus 3. So 2 times 7/2 is 7. 7 minus 3 is 4. So the length is 4 meters. So this would be 4 meters for the length and 7/2 for the width. You can also check it if I were to do 4, which is the length, times 7/2, which is the width. Not surprisingly, I get 14. So, kind of a quick explanation. Hopefully this clears it up a little bit for you. Obviously, let me know if you have more questions.